All right, Unit 2. So obviously, you're not going to be working with a partner on this. So you can hit pause and try to come up with these on your own or just watch. So it says a hypothesis can either be a true or false. Okay? Determine whether each conditional statement is true or false. Justify your answer. So it says if yesterday was Wednesday, then today is Thursday. All right? Well, is that true or false? If yesterday was Wednesday, today is Thursday. Well, that's obviously true. Why? That is the order of the days of the week. You can put this any way you want. That's how days work, whatever. Just a general idea. That's the order of it. If an angle is acute, then its measure is 30 degrees. Well, as an absolute statement, it's false. So, because it could be more than one. I would also say not necessarily. In other words, it can be true, okay, but it's false because it's not the only acute angle measurement. Because acute means less than 90 degrees. So 30 degrees is acute, okay, but it's not the only acute angle. If a month has 30 days, then it is June. All right, so this is like the previous one. It is false. Okay, I'm not going to say not necessarily, but it's the same concept because June does have 30 days. But why is it false? June is not the only month. With 30 days. For example, April has 30 days. Okay, so 30 is not the only acute angle measure, and June is not the only day with 30 days. If a number is not divisible by 2, then it's not an even number. Okay, that's true. Because if it is divisible by 2, it's even. If it's not, it's odd. And if it's odd, it can't be even. Kind of some common sense there. All right, conditional statement. A conditional statement is a logical statement that has two parts, a hypothesis, P, and a conclusion, Q. When a conditional statement is written in if-then form, they don't all have to be written this way, and we'll be seeing that soon. The if part contains the hypothesis, the then part is the conclusion. So if P, then Q. We could also use a symbol that means P implies Q. So for example, if, you stay up late, then you will be tired. Notice the key words here, if then. What follows if is the hypothesis, and after that is the conclusion. So if x plus 8 equals 8, then x equals 3. Hypothesis, conclusion. All right, rewrite the conditional statements in if-then form. Use red to identify hypothesis and blue to identify conclusion. Well, you don't have to use two different colors. We can just label it. So this is not written in if-then. So all birds have feathers. So something like this, and you can write it any way you want. If a creature is a bird, then it has feathers. All right. So if a creature is a bird, we'll call that the hypothesis. Then it has feathers. That's our conclusion. You are in Texas if you are in Houston. Now notice this is kind of backwards. Here's my if right here. Here's my hypothesis. So to rewrite it as an if then, I just move that to the front. If you are in Houston, then you are in Texas. This one is just missing the then. And it wouldn't make sense to start off saying, then you are in Texas if you are in Houston. It doesn't make sense. Then you are in Texas. So here's my if. The statement after that is my hypothesis. Here's my then. The statement after that is my conclusion. All right, negation. Okay, negation is like dealing with a toddler who's always saying no, in a sense. The negation of a statement is the opposite, very key. It's the opposite of the original statement. To write the negation of a statement, we use this little symbol, the tilde, before the letter. So not P is written tilde P. All right? The sky is blue is my original statement. The sky is not blue is my negation. Hexagons have 6 sides. Negation, hexagons do not have 6 sides. So write the negation of each statement. If the ball is red is my statement, you simply say the ball is not red. The cat, now here is the thing. You can't always say add not, because this is saying the cat is not black. Well, we would not say the cat is not black, even though, that works. We would just say the cat is black. If we add another not and said not, it's the same thing because they undo each other. All right, related conditionals. Consider the word conditional statement below. Words, if P, then Q. Okay. Now we have a new one called the converse. To write the converse of a conditional statement, exchange the hypothesis and conclusion. So we're basically just switching it. So instead of saying if P, then Q, we're going to say if Q, then P. So we just flip-flop. The inverse, all right, to write the inverse, negate both of them, of the original one. So if not P, then not Q. All right? So converse, you flip them. The inverse, you keep it the same order, but negate them both. And then the contrapositive. All right? It says to write the contrapositive, first write the converse. Okay? So we're going to flip it first. And then negate it. So the contrapositive is kind of like combining the converse and the inverse. So a conditional statement and its contrapositive are either both true or both false. Similarly, the converse and inverse are either both true or both false. In general, when two statements are both true or both false, they are called equivalent statements. So let P be you are a guitar player. Let Q be your musician. Write each one. So this is my P. This is my Q. So conditional statement, if P, then Q. So if you are a guitar player, that's supposed to be an R, then you are a musician. Now the converse, we just flip it. If you are a musician, then you are a guitar player. Now some of you might be saying that's not true necessarily, kind of like the acute 30 degrees. But we're not talking about true or false, we're just flipping them. You are a guitar player. Now for C, the inverse, remember, we're keeping the order of P and Q, we're just negating them both. So we're just adding not. If you are not a guitar player, remember, we're keeping the same order as the first one, then you are not, we're negating them both, a musician. All right, and now the contrapositive, we're going to flip it and negate it. So we're going to kind of take the converse and add not. So if you are a musician becomes if you are not a musician, then you are not a guitar player. Okay, so just a review. We have our standard if then, P then Q. The converse, we switch it if Q then P. The inverse, we negate the original conditional statement, so if not P then not Q. And then the contrapositive, we flip it, Q then P, but negate them both. So if not Q then not P. All right, if two lines intersect to form a right angle, then they are perpendicular lines. Okay, line L, remember we use the cursive for lowercase, is perpendicular to line M. This is how we write that. L is perpendicular to M. This upside down T is a symbol for perpendicular. And as always in geometry, we cannot assume. You may not assume lines are perpendicular unless you see the box. So just because something looks 90 degrees, we've talked about this before, and in fact, we found out this could be 89 degrees or 91. We must have the box to know it's 90. All right, decide whether each statement about the diagram is true. Explain your answer. Okay, notice we have our box. AC, which is this line right here, is perpendicular to line BD right here. Yes, it is. Why? We have the box. AEB, which is this angle right here, and CEB right here are a linear pair. That is also true. Yes, because they form a line, AC. EA, so remember we're starting here at E, going out towards A, and EB, going this way, or opposite rays. Well, that's a big old no. Okay? They are not opposite direction. Okay? Okay, a biconditional statement. When a conditional statement and its converse are both true, you can write them as a single biconditional statement, which means we're going to say if and only if. Notice it's not going this way like before, where P implies Q. It's going both directions. So rewrite the statements as a single biconditional statement. If you can run for president, then you're at least 35 years old. If you're at least 35 years old, then you can run for president. So You can run for president if and only if you are 35 years old, at least. I have to say at least, otherwise you can only be 35 years old. Okay, so this is the important part: if and only if. All right, exit ticket. Again, you're going to do this on your own. So when you're doing this for practice, look back at example 3. Okay, so you're going to do the exit ticket on your own, and we'll discuss it in class.